Here we are going over our review sheet for our rational numbers test. Okay. Number one, we're just going true or false. If false, we're going to change the underlying word to make the statement true. Every counting number is a natural number. That is true because they're synonyms. B, every natural number is a whole number. That is also true. The only whole number that is not a natural is 0. So that would be going the other way. Every natural number is an integer. Also true. -5 is a member of the whole numbers. That is false. There are no negative numbers in the whole numbers. It is a member of the integers. Or we could say rational, or we could say real numbers. Every non-terminating, non-repeating decimal is rational. False. Okay? Non-terminating, non-repeating decimals are irrational. Now, F is the one that gets people. The numbers square root of 5, square root of 9, and square root of 20 are all irrational. Well, not quite, because square root of 9 is rational. It's equal to 3. These numbers are all real numbers. So that's how we would answer that. On number 2, naming our properties, if we need a review of those names, we can look them up in our skills review booklet. Okay, this is something we could see maybe as a multiple choice question on the test. Okay, not a big portion, just a, hey, we're still using these concepts. 5 plus 6 equals 6 plus 5. That's going to show us our commutative property, and it's fine if you abbreviate. Okay, let's see. Our next one is showing us the associative. Then we've got our multiplicative identity. The number times 1 is just itself. A times B plus C equals A times B plus A times C. There's our distributive property. H times 0 equals 0 equals the zero product property. 28 plus 0 equals 28. That's our additive identity. 7/9 times 9/7 equals 1. Our multiplicative inverse. -4 plus 4 equals 0. Our additive inverse. On 3, we're simplifying. Okay, so again, another little review topic. We're going to simplify inside the absolute values first. Take our absolute value. Oh, that's right, it's negative. 4 times -1, -4. 4 minus -1, same sign, sign. 4 plus 1 is 5. -0.3 repeated in absolute value, so -0.3 repeated. We can write it as a fraction also, either one. -3 minus 7, -10. Little PEMDAS down here on number 4. -48 divided by 6 times 2. It's going to be -8 times 2, working from left to right with multiplication and division, so -16. Now here we want to be careful. That's team game. Right? Negatives have 4, 3, and 2 points. Positives have 5. Negatives win by 4. Let's see, that's 5 times the absolute value. 9 minus 13 is -4. So 5 times 4, which would be +20. On 5, we're evaluating the expression. So we're going to substitute in and then simplify. Okay, so we've got 3 times x to the 4th. X is -2. So the 4th power minus, and then y is -10. Now -2 to the 4th power, negative number and even number of times, that's going to be positive. 2, 4, 8, 16. 3 times 16. Here we can combine the double sign, plus 10. Okay? 3 times 16 is 48. Plus 10 is 58. So let's try it again. 5x to the 3rd minus y squared. So let's see, that's going to be 5 times x, which is -2. Minus y squared, which is -10 to the 2nd. Now notice you cannot combine that double sign there. Okay. -2 to the third is going to be -8 minus -10 squared is going to be positive 100. That would be -40 minus 100, right? It's that minus, because we brought the minus down there, is going to be -140. Okay, and last but not least, we're going to circle all the irrational numbers. So 2/5, that's rational. Square root of 36, that's 6. Square root of 64 over 4, that would be 8 over 4, which is 2. 0.5 repeating is 5/9. That's a fraction, so it's just square root of 20, right? That non-perfect square there. On page 2, we've got a variety of simplifying, so some integers, some fractions, whole good mix. Okay. All right, so A here really is just combining double signs in team games. Remember, combine your double signs and then rewrite. So we've got 54 minus 36 minus 27 plus 13. We can go off and do our team game. So negatives have 36 and 27. Positives 54 and 13. So that'll be 67 and 63. So positives win by 4. Okay. On B, simplify inside our parentheses first. So that'll be 4 times -4 minus 5 times -6. Next we'll do our multiplication. So -16, -5 times -6, positive 30. -16 plus 30, positives win by 14. On C, 3 and 1/15 plus -3.4, right? I can see, oh, double sign, difference, 3.4, 3 and 4/10, or 3 and 2/5. I'm going to take these, I'm going to make them improper fractions. 15 times 3 is 45, plus 1 is 46/15, minus 5 times 3 is 15, plus 2 is 17, 17/5. Now our common denominator is going to be 15, so times 3 times 3, so that'll be 46 there. And then 17 times 3, 10 times 3 is 30, 7 times 3 is 21, so it's going to be minus 51, so negatives win by 5. So -5 over 15, which reduces to -1/3. We always must reduce. Our answers are always going to be in lowest terms. Okay. On D, I see a double sign, same sign, sum. I also might notice that 18 and 28 can be reduced. They have a common factor of 2. So that would be 9 over 14 plus, oh my gosh, look at that. 9 over 14, aren't you glad we reduced, because now we have a common denominator, which would just be 18 over 14, which can be reduced again by a factor of 2, which would be 9 over 7, or 1 and 2/7, leaving as improper fraction, totally fine. Different signs. Difference, -1/4 plus 2/5 plus 5/3 minus 1/2. So I'm seeing 20, but 3 doesn't go into 20. Some people might be tempted just to do 20 with the 4, 5, and 2, and then go from there. I'm just going to go for it. Let's do 60 as our common denominator. So that'll be, let's see, times 15 times 12 times 20 and times 30. Numerators aren't too big, so it shouldn't be too bad. 15 times -1, -15. 12 times 2, 24. 5 times 20, 100. And -1 times 30, -30. Now we can set up team game with just our numerators. So negatives have 15 and 30. Positives have 124. So 124 for the positives and 45 for the negatives. So positives win by 79. Okay. So 79 over 60. Only common factor I would think to check here would be 3. 7 plus 9 is 16, so it's not divisible by 3. So we could say 79/60ths or 1 and 19/60ths. On F, 5.7 repeating, we have to make sure we see that as 5 and 7/9. Okay, now we can make those improper fractions. 45 plus 7 would be 52/9 minus 52/5. That's fun. Still need a common denominator, which would be 45. So times 5 and 5, times 9 and 9. And if I need to go off to the side and I need to do 52 times 5, paper and pencil, I can do that. Go off to the side, do it. Right? 5 times 2 is 10, caret. 5 times 5 is 25, plus 1 is 26, so that's going to be 260. Go off to the side, do 52 times 9, right? 9 times 2 is 18, 9 times 5 is 45, plus 1 is 46, 468 there. All right, so we're going to have 260 minus 468. We're going to find their difference. Okay. So the difference would be 208. So negative 208 over 45. And the only factor I would think to check there is factors of 45. I'm thinking of 5, 9, 3, 15. I would only check 3, not divisible by 3 there. Okay. Ooh, finally, some multiplication and division. Good. Right, so I'm thinking cross canceling. I also want to notice 18 over 45, that can reduce. I'm going to reduce it. Negative 6 over 7 times 5 over 12 times negative 2 over 5. Common factor there was 9. Okay? So now we look for cross canceling. First thing that pops up to me are the 5s. 5 divided by 5 is 1. 5 divided by 5 is 1. And then the negative 6 and 12. Common factor is 6. 12 divided by 6 is 2. Negative 6 divided by 6 is negative 1. And now we can just multiply straight across. Negative 1 times 1 is negative 1 times negative 2 is positive 2. 7 times 2 is 14 times 1 is 14. Right? Oh, we can reduce 1/7. Okay. H, you want to remember here that we're actually dividing. Negative 3/4 divided by negative 1 and 2/3. We got to make that improper. So negative 3/4 divided by negative 5/3. Keep, change, flip. We look for cross canceling now that we're in multiplication. There is none, so we just multiply and we get positive 9/20. Okay. On I, negative 4 1/8 divided by negative 2.75. I want to realize as a mixed number, that's negative 2 3/4. Okay, rewrite as improper. That's going to be negative 33/8 divided by negative 11/4. Keep, change, flip. Ooh, yay, cross canceling. Okay. So let's see, between negative 33 and 11, common factor is 11. 11 divided by 11 is 1. Negative 33 divided by 11, negative 3. Negative 4 and 8, common factor is 4. 8 divided by 4 is 2. Negative 4 divided by 4 is negative 1. Now we just multiply, and we get positive 3/2. On page 3, we're evaluating the expression, so we're going to substitute in using parentheses. Remember, we're always going to use parentheses when we're working with multiplication, exponents, and double signs. If we don't have those, then we don't need to keep them. Okay? So E is 4 divided by, so 4, I don't need parentheses around it, divided by G, which is negative 1/3. I'm going to leave a parenthesis there. Okay? So we're dividing, so that should really be 4/1 divided by negative 1/3. We're going to keep, change, flip. No cross canceling, and we get negative 12. On B, 2G squared plus F, we've got 2 And then we're going to substitute in for g, which is negative 1/3. We've got those parentheses. We've got an exponent plus f, which is 6. Now we want to remember that negative 1/3 squared, that means negative 1/3 times negative 1/3, which is positive 1/9. That's going to be 2 times 1/9 plus 6. So 2 over 9 plus 6 over 1. Common denominator would be 9, so that's going to be 2 plus 54, which would be 56 over 9. Wow, that's a mess on the board there. So 56 over 9, that can't be reduced, and there we are. Now, f minus g, that's going to be 6 minus, and then the g is negative over e, which is 4. We've got a double sign there we can add. Okay, so 6 plus 1/3. So we can really just think of that, oh, that's 6 1/3 divided by 4, or 19/3 divided by 4. Keep, change, flip, no cross canceling, and we get 19 over 12. On 9, we're simplifying our longer rational number expressions. We've got negative 1/4 minus 4 times 3 minus 5½ plus 5/8. So PEMDAS, we're going to work inside the parentheses. I'm also going to rewrite everything as an improper fraction to help us with our problem solving. Inside the parentheses, we need a common denominator, which would be 2. So we're going to do times 2 times 2. Again, just working inside the parentheses. So negative 1/4 minus 4 over 1 times 2. So it's going to be 6 minus 11 plus 5/8. Negative 1/4 minus 4 over 1 times negative 5 over 2 plus 5/8. Next step, we're doing this multiplication. Now the multiplication is right here. Negative 4 times negative 5 over 2. So that's the only place I'm looking for cross canceling, and we've got it with the negative 4 and the 2. Common factor is 2. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. So bring everything else down. Negative 2 times negative 5, positive 10. Positive 10 over 1 plus 5/8. Okay. We can see our common denominator is going to be 8 times 2 times 2 times 8 times 8, which is going to give us negative 2 plus 80 plus 5, which would be 83/8. On B, it's a little more challenging with the repeating decimals. We need to take those and change them to fractions. So I notice, oh, negative 0.6 repeating, that's negative 2/3, negative 2.3 repeating, negative 2 1/3. So we're going to change the fractions and change the improper fractions. Negative 2/3 minus 3 over 1 times 5 over 6 minus 7/3 plus 1/2. Working inside those parentheses, getting our common denominator, which will be 6. So continuing, we're going to have negative 2/3 minus 3 over 1 times. We're going to have 5/6 minus 14/6 and plus 1/2. So continuing, negative 2/3 minus 3 over 1 times negative 9 over 6. We notice that can be reduced. So you can reduce that right there if you want to. Otherwise, I notice I'm looking at the multiplication, negative 3 over 1 times negative 9 over 6. We're going to have cross canceling there anyway. Okay. So our cross canceling, common factor is 3. 6 divided by 3 is 2. Negative 3 divided by 3 is negative 1. So our multiplication now is negative 1 times negative 9 over 2, which would give us positive 9 over 2 and plus 1/2. If we wanted to just go ahead and say, oh, that's 10 over 2, that would be fine right there. Otherwise, we're going to be getting the same common denominator of 6, so you can leave them separate also. should have negative 4 plus 27 plus 3, okay, which is going to give us 26/6, which can reduce to 13/3. With our complex fractions, we want to remember we're going to simplify the numerator, simplify the denominator, and then divide. So step 1, our numerator, I'm just going to work and rewrite it with improper fractions. Negative 2/3 plus 5/2. Common denominator would be 6, so that's going to be times 2 times 2 times 3 times 3. Negative 4 plus 15, which would give us 11/6. Not our final answer, but important. Okay, so now let's look at our denominator. Okay, so that'll be negative 6/5 minus 1/4. Common denominator would be 20. So negative 24 minus 5/20, negative 29/20. Now we have to remember the third step, that division, is going to be numerator divided by denominator. Numerator divided by denominator. So that'll be 11/6 divided by negative 29/20. Keep, change, flip. Cross canceling with 6 and 20. Oh my gosh, for the first time ever, I didn't leave my numerator up top. My negative up top in the numerator. Let me fix that for myself. 6 and negative 20, common factor is 2. 6 divided by 2 is 3. Negative 20 divided by 2 is negative 10. So that should be negative 110 over 58. Okay. And, oh, excuse me, not 58. Okay, let's see, 29 times 3. 87. Okay, negative 110 over 87. Let's take a look to D here. With D, we have to be careful of our double signs as well as our repeating decimals. We've got same sign sum. So as I simplify our numerator, I've got negative 1/3 plus 2/5. Common denominator will be 15. Negative 5 plus 6 over 15, which will give us 1/15. And then our denominator, 3/4 minus 7/5. Common denominator will be 20, which would be 15 minus 28, negative 13/20. And in the last part here, we're going to be doing that numerator divided by the denominator. And again, we're going to keep, change, flip. We can cross cancel. Common factor is 5, which will give us negative 4 over 39. On page 4, we're taking a look at our word problems. Number 10, the sort of that mystery number problem. The sum of two rational numbers is 41 over 51. If one of the numbers is 6/17, then find the other. So sum, I know we're adding two things, and it's going to equal to 41 over 51. If one of the numbers is 6/17, what's the other one? Now, the nice thing about it being fractions and adding, we know there has to be a common denominator. So with 51, I'm thinking, ooh, I bet 17 goes into 51, and it does. It goes in 3 times. Okay. So to get our common denominator here, I'm going to do times 3 times 3. Okay. And then that's 18 over 17 plus something over 17 equals 41 over 51. Now, if you can just see, you can see what it is out of 18 plus what equals 41 over 51. You can write your answer here right now, make sure it's reduced, and that's enough work shown. If you don't see it, that's where now we want to go through, okay, how can I figure this out? Well, we're going to do the opposite. We're going to do 51, the sum, minus the add end. Oh, and I wrote 17s there. I shouldn't have written 17s there. So we multiply by 3 and we get 18 out of 51 plus something out of 51 equals 41 out of 51. Some of us might be able to see what our mystery number is right now from this setup, and if you do, that's great. Write it down, reduce it. That's enough work shown, this setup. If we don't see that, then we want to go through and do the opposite. Take our sum, subtract our other addend to find our missing number. So 41 minus 10 is 31, minus 8 would be 23. So 23 over 51, that can't be reduced, and that's our answer, 23 over 51. Okay. With 11, same type of problem. The sum of two rational numbers is negative 3/8. One of the numbers is 1/6, find the other. So we're adding two numbers. It equals negative 3/8. One of the numbers is 1/6. What's the other? So common denominator between 6 and 8 is going to be 24, which will give us 4/24 plus something out of 24 equals negative 9/24. Okay? So we might be able to see, oh, that's negative 13/24, write it down. If you can't see it, set it up again, sort of that backwards method, negative 9/24 minus 4/24. Oh, that's negative 13/24, and there's our answer. Can it be reduced? Nope. So we're good. 12, just kind of a general word problem. 4/5 of the weight of a pineapple is water. About how many pounds of water would you expect to find in 2.5 pounds of pineapple? So 4/5 of a pineapple is water. This pineapple weighs 2.5 pounds. So we're really going to be looking for what's 4/5 of 2.5. So we're going to multiply 4/5 times 5 over 2. Woo, look at that cross canceling. It's a beautiful day. And we should get 2 pounds. Okay? So our answer with the label, 2 pounds of water. Okay. 13, I really like this problem. I think it's a very realistic problem too. You are making 20 fleece jackets for a craft fair. For each jacket, you need 1 7/8 yards of fleece. If fleece costs $9 per yard, how much money will you spend? Okay. Now, this isn't a one-step word problem. It's multi-step. Because first, we have to figure out, well, how much fleece do we need? Okay, so to figure out how much fleece, we're going to do 20, because 20 jackets, one jacket is 1 7/8 yards. So we're going to multiply. That'll be 20 over 1 times 15 over 8. We have a little cross canceling here. So that would be 75 over 2. Or, let's see, that would be, I believe, 37.5 yards. And just giving myself some options with the formatting there. So I don't know on the next part what's going to be better, improper fraction or mixed number, but I've got it both. Okay. Second step, we want to figure out, well, how much will it cost? We need to figure out the money. 1 yard costs $9. We have 37.5 yards, so we have to multiply. 37.5 or 75 over 2 times 9. Okay. And you can do it anyway, right? We can leave it as fractions. We can also convert to a decimal, kind of knowing our answer is going to be muddy, and a decimal might be more appropriate. So I think I'm going to do that. So I'm going to do 37.5 times 9 and do my multiplication out. One decimal, so that's going to be $337.50. Remember, formatting, we want our decimal sign, and we always go to the hundredth if we have cents. So $337.50. Okay, 14. Big important word problem number 2 we went over. Put a star next to this. We can bet money we're going to see this on the test. Miss Smith has 100 pencils. She gave out 4/5 of them to her students in September and gave out 1/4 of the remainder in October. How many pencils does Miss Smith have? So she has 100 pencils. She gave out 4/5 of them to her students in October. So we're splitting it into fifths. The denominator of fifths is 5. So I'm going to draw out 5 boxes. 1, 2, 3, 4, 5. We're going to split those 100 pencils evenly into fifths. So I'm doing 100 divided by 5 is 20. So each of the boxes gets 20 pencils. And we can see it adds up, 20, 40, 60, 80, 100. 4/5 are given out in September. So I'm going to cross out 4 boxes. That's what's given out in September. Okay? These 20 are what's remaining, 20 remaining. Of the remainder, she gives out 1/4 in October. 1/4, we're going to split into fourths, denominator is 4, so now I'm going to make 4 boxes. Okay, so those 20 are going to get split into fourths. Okay. How many are going to go in each? Well, 20 divided by 4 is 5, so we're going to put 5 in each. She gives out 1/4 in October. How many are left? Well, these 3 5s, so we have 15 left. Okay. And as any teacher knows, those will go real fast. Okay. Now on 15, this is big important word problem number 1. We can bet money this one's going to be on the test. A 9 1/4 foot piece of fabric is cut into 1 3/4 feet pieces. Find the number of whole pieces that can be cut from the fabric. Right, we said that word cut was a clue that we were going to divide. So we're going to do 9 1/4 divided by 1 3/4. So that'll be 37/4 divided by 7/4. Now we're going to keep, change, and flip. We've got cross canceling here. This gives us 37/7, which isn't helpful. Make it a mixed number. That would be 5 2/7 pieces. Right, so how many whole pieces? 5 whole pieces. Now the part that gets people is part B. How much fabric in feet is left over? From part A we have leftovers for 2/7, but that's 2/7 pieces. Right now our leftover is 2/7 of a piece. We have to think, what is that in feet? 1 piece is 1 3/4 feet. So we're going to use that fact right down here. If we have 2/7 of a piece, that means we have 2/7 of 1 3/4 feet. So just like our pineapple problem, that of we're going to multiply. So we're looking for what's 2/7 of 7/4. We cross cancel, and we get a 1/2 foot. There we are.